Alright guys, water for living. So now we're going to look at the hydrological cycle and how using certain sources of water affects the environment. Okay, so what's the point? Basically, by the end of this, you should be able to define various sources of water and the issues associated with the use. You want to identify issues with using various sources of water. And you also basically, you want to be able to reproduce a hydrological cycle. You need to be able to do that with detail. Okay, so transpiration. Basically, transpiration returns water from vegetation to the atmosphere, and you need to know that plants also draw water up from the soil. Okay, so what is the hydrological cycle? Is basically it's the cycle which water moves around the earth in all three states: solid, liquid, gas. Um, Water can be locked away as a solid, so it's ice at the poles, or stored beneath the surface of the earth for long periods of time. But this water always makes its way back to the surface. Eventually, it'll get there. That's the process of percolation. So basically, water can be collected at various surface sources as well as some groundwater sources. So let's have a look. Now, the water here in the ocean, and it all evaporates. Now, some of that water will evaporate back into the ocean. In fact, most of that water will. By the way, each of these numbers here is 1,000 cubic kilometers. So that's a volume, cubic kilometers per story. So this one here is, so the ocean holds 1,335,040,000 cubic kilometers of water. And this is, if it's moving, that's how many thousands of cubic kilometers per year gets moved around the world in that way. So most of the ocean evaporation gets dropped, redeposited. Then it gets the rest of it, which doesn't, will move over land to evaporate. Some of which will go up into the atmosphere and kind of stay there. Some will stay as water vapor, and it will precipitate out. Okay, now this is also being added to with evapotranspiration, so transpiration from the trees moving up, and that will then also precipitate down. Percolation is also happening where the surface waters, where so the water lands here in the rivers and lakes and whatnot, it drips back down through the surface into the bedrock and moves across into the oceans. That's your hydrological cycle. Know that. That's really important. So where do we get groundwater from? So you bore water. About 60% of people, 60% of Australia, not 60% of people, 60% of the landmass is totally reliant on bore water, and it's water pumped from underground to the surface. There is artesian water, which is a water collected in an underground reservoir or storage place, and about 22% of the Australian continent is over top of artesian water. An aquifer is basically an underground layer of water-bearing permeable rock. In other words, it's rock that holds water inside it, water that you can pull out, or gravel and silt as well, but also rock, from which water can be extracted using a well. The water table, it's basically the level at which when you dig down, you reach water. Okay, so here's a little diagram. So here's the aquifer. Here is just some water in there, buried in the rock, as you know, so there'll be a patch of water, and you'll notice that the aquifer comes down with the river. Okay, now that's natural. This line here is the water table. So no matter where you are, if you dig down and you hit that point there, you're going to find water. And here are the Australian artesian basins, and you'll see that about 22% of Australia has water underneath it, large amounts of water. Dubbo up here, we're just down here a little bit. You can see Dubbo is right over top of the artesian basin, but so is Brisbane and Longreach and Oodnadatta in South Australia, and part of the Northern Territory. Alright, so surface water. Basically, we've got dams, which are artificial bodies of water. We've got rivers, which are large, natural way for that project into a larger source of water, and this is usually the oceans. You've got a lake, which is moving water, which is naturally occurring. So it's not water that's sitting still. It's got like currents and whatnot in there. We've got a wetland, which is essentially stuff like your swamps or whatever, and it's basically where your terrestrial and your that should say not ecological, what's the word? Terrestrial and aquatic environments meet. And we've seen these, such as the Homebush wetlands. And here is essentially a map of the surface water. Okay, so this is groundwater in New South Wales. And this is all your surface water. These are your big bodies of surface water that we have. So water pollution is a pain. Basically, it's pollutants like chemicals and garbage, which are washed into waterways. Agricultural and industrial chemicals can also be washed into the rivers. So stuff gets washed into the waterways and it stays there, having usually a negative effect. What are those effects? Basically, animals can swallow or choke on plastic products, cigarette butts and whatnot. Plants get killed when they're covered by plastics, or they get poisoned by heavy metals. Orica released a bunch of toxins into the water at Rockdale, and this contaminated that. It happens. Farming is constantly releasing phosphates and nitrogens and whatnot. We'll get more into that later when we start talking about fertilizers into the waterways. This is the Pacific Ocean. That's right in the middle of it, actually. It's what we call the Great Pacific Ocean Dump, or plastic vortex, and essentially it is thousands upon thousands of tons of rubbish. This is what happens when you put rubbish in your drain. It flows out to the ocean. Nemo taught us, all drains lead to the ocean, and they do. And because all drains lead to the ocean, the plastic doesn't break down. It hits probably the East Australian current or another current, and it gets swept up into the Pacific Ocean. Like, there's garbage from Australia there. This is another underwater dump of tyres, and you can see how far back that goes. This is a bird that fed in the Pacific Ocean, and that's the stuff that it picked up when it was eating fish. Here's a turtle from the same spot, and it's had a plastic ring around cans. They don't even make those anymore. That's a photo from last year. They don't even make those anymore, and still they're out there. And it would have got around this turtle when it was really small, and the turtle kept growing, and it's grown around it, and that turtle obviously is not in a good way. So let's move to something that's almost as depressing: salinity. Basically, ground salinity, as you know by now, is a measure of the amount of salt in the soil. Primary salinity is the naturally occurring salt, and the secondary salinity is the stuff that occurs because we put it there or we did something. So secondary salinity is human impact. Now, it doesn't just measure table salts like sodium chloride, it also measures magnesium and calcium. Now, it can increase from runoff where erosion has occurred. So sedimentary rocks, when they're mostly made up of salt. So when they erode, sure, it will increase there. But when the water table rises, it dissolves those salts and brings it up. So as the water table rises from use of bore water, it brings salt up through the ground and makes the soil saline. So we can see it here, right? So we pump from this well, and we're using all this water here. But what this actually going to do is it's going to lift the water table up with it. It'll bring it all up. It'll float up higher. Now, this obviously doesn't sound like it's a party, so what effect can it have? Basically, as it brings up the salt, they'll accumulate in the surface. Plants draw this water up further, and remove it, leaving the salt behind on the surface due to evapotranspiration. Now, the extreme results are salt pans. So this is where salt rises across the surface, but it also may kill off vegetation or eliminate a lot of the vegetation that will be replaced by salt-resistant species. Now, that's not a great idea either, because the drinking water of animals may become contaminated or brackish, but the salt-resistant vegetation may also be probably is indigestible to many animals. There's too much salt, they can't eat it. So the animals don't just lose a water source, they lose a food source as well. This one is in South Australia. This is in South Australia. That's huge. That's just ground salt. That's salt that's come up from the ground. So that's in Western Australia. No, South Australia, Western Australia. This is the result of some very heavy usage of water for a local mining operation. And you can see that nothing grows around it. It kills off the soil. Nothing grows around there. Kills it off, and it will never grow again. It's well, not in our lifetimes anyway. And it's a very, very, very long road to recovery for that to get better. So that was cheery. I'll see you in class.